So welcome to this new question, critical connection. Critical connection. In this question, what we have to do? We have to do just one thing. Here, the one has how many connections? So what is the critical connection? When we remove this, when we remove any edge, then the graph should be divided into two parts. So this edge is called a this graph is called a critical connection. So this edge is called a critical connected edge. Okay. So when we remove any edge, then the graph is divided into two parts. Then that connection is called a critical connection. This edge is called a critical edge. Okay. Like this part, if we remove this edge, then this graph is divided into two parts. The graph is divided into two parts. So this is our critical edge. This is our critical connection edge. Okay. So so you understand what is a critical connection? So what is the difference between articulation point and critical connection? In articulation point, we are removing any edge, we are removing any vertex like this. If we remove this vertex, if we remove this vertex, then this graph is divided into two parts, and this is called a articulation point. Okay, so this is a difference between critical connection and articulation point. So how we can solve this question? So this question, what we have to do? What we have to do is, in this question, same we have to find three things: a low value, and we have to find three things. First is low value, and the second is discover value, and the third is parent array. Okay, so three things: low vertex, low value, discover values array. So we have to find three things: low array, low value array, discover value array, parent array. Okay, so how we can find this thing? Initially what we are doing, we just update our low value. We update our low value equal to discover value. Okay, so what is our discover value? Discover value is a stage where our value is discovered, where our the vertex is discovered. Initially, this vertex is discovered at one stage. This vertex is discovered at second stage. This vertex discovered as third stage. This vertex discovered as fourth stage. This vertex discovered as fifth stage. This vertex discovered as sixth stage. This vertex is discovered as seventh stage. This vertex is discovered as eighth stage. Okay. Initially, we made a low value equal to discovered value. What is the minimum? What is the value of what is the meaning of low value? Low value means when any vertex calling the point to a minimum vertex. When any vertex point to a minimum vertex is called a low value. Like 2 will point itself. But what we have to do? We have to just ignore the previous path. Okay. So we have to just ignore the previous path and we have to find the low value. So how we can find low value array? We have just go and make initially we make a discover value equal to low value. So low value equal to 1. And here also 2, here also 3, here also 4, here also 5, here also 6, here also 7, here also 8. But at some stages we have to update the low value. At which stage? We have to just put our conditions like if. So for ignoring the path, like when we call 4, then how we can decide our low value? First, we have to ignore the path of previous path. We have to just ignore this path and then we have to update our array. First, I have to tell that you have to just go and watch the articulation point video. Then you have to just come here. Okay. So if 4 has like if our neighbor, like what if our parent array, if our parent, what I'm saying, if uh src, if our neighbor, what I'm saying, if our neighbor is parent, then we have to continue. Our neighbor is parent, then we have to continue. Else, if our neighbor is wasted, then we have to update our low value. Okay, then we have to update our low value with its low value, our low value, and discover of neighbors. Okay, discovery value of neighbors. And the third condition is else if. Else if in the third condition. What is the third condition? Third condition is if, else if. Else if here. and else in this condition we just call a DFS. We just call a DFS, and where we just get at another neighbor, and when we are backtrack it, then we have also update our low value with minimum of own no value. It means low value of RC and low value of neighbor. Okay, and then we just check out what is our critical point. Okay, so the whole thing is like so the whole thing is same as critical, same as articulation point. Okay, some edge cases will remove like when we call at this stage like 2 times because we are not finding any node, we are finding an edge, so we are just removing the edge conditions. Okay, so in the critical connection, so when we are going to find a critical connection, we have to care about some things. Like when you in the articulation point, what is the condition to find out critical? What is the condition to find out articulation point? If the low value of neighbor, is greater than or equal to discovered value of SRC, then this is called a critical, called a articulation point. Articulation point. Okay, this is called articulation point. But here what? Here we are not provide this check. This is the only difference, that here we not provide this check. Why we are not providing this check? Then we can find out critical connection. Why we are not providing this check? First we understand how we can find articulation point. Okay, so at the stage of this, what we are waiting, our neighbor, like we take a 2, and the low value of 8 is like 7. I think the low value of 8 is 5, 6. The low value of 8 is 6 and the low value of 2 is 5. So why 2 is our articulation point? When we remove 2, then the graph is divided into 2 parts. So this is articulation point. But why? We check at this condition. The 2 have two neighbor 6, but this is our parent. So we have to ignore this path. Okay, and when we ignore this path, then we have to check out another neighbor, which is 8. If the if the low value of this neighbor is greater than or equal to discovered value, like 2, like the discovered value of 2 is 5 and the low value of 8 is 6, it means it cannot go here. Because the discovery value is, the low value is 6. It means it can be minimum point to 6. It cannot minimum point to 6. It cannot point the minimum value of 6. Like it can point only 6 to 7 to 8. It cannot point 5, 4, 3, 2, 1. Okay, it can point 5 because we put a condition of equal. This is the reason we remove this equal. Why? It can point to 5. It can point 5. But if it can point beyond the 5, less than 5, then it is not a critical point. Then 2 is not a critical point. But if the low value of neighbor is greater than or equal to discovery of source value, then it can be articulation point. Because if the reach of 8 is beyond than 2, then it cannot be articulation point. So reach is limited here. If reach is at this stage, then it can be articulation point. But at the term of h, this condition is not valid. We have to remove this equal condition. Why? Because when we put an equal condition now, then it can check here. But when we remove this, then it can go from another edge. Now it can go from 5. It can go from 5 to 2. It means the low value of 8 could be 5. Could be 5 from that node. What I'm saying, you just understand. Suppose this 8 has low value 5. Suppose this 8 has low value 5. Then how low value 5? 8 is pointing to 5 and 5 is pointing to here. So if 8 has low value to 5, then it can point to 2. Then the low value of 5, then the low value of 5 is greater than or equal to NPR. Then also 2 is articulation point. But at the term of edge, this is not a critical connection edge. Because when you find out, if you put equal condition, then it decided that this is our edge. But when we remove this edge, then this graph is not divided into two parts, because the reach is the equal condition will make the graph from that part, will tell us that it is connected with this edge. Okay, so when we remove this edge, when we remove this edge when we remove this edge, then also the graph will connected. Okay, so we have to not put a equal condition, because equal condition can make we using another edge. Okay, this equal condition tell us that it can be go to this graph equal by this edge. Okay, so we have to just remove this equal condition. We have to just remove this equal condition, and all thing is same in the articulation. So we have to just go and code it. Okay, so I think you have to just understand everything. So now we are going to code this problem. Okay, thank you so much. So I'm going to code it. So here what we have to do, we have to just call a discover src, then after that we have to just update our low src according to this, and after that we have to just increase timer. Okay, after that for that we have to just increase the timer, and then we state of src equal to true. Okay, and after that what we have to do, we have to just find out all edges. Okay, int I equal to 0, we are taking just e. Okay, we are just taking e equal to 0. We are just taking e equal to 0 and e less than graph dot get rc dot size, and then we just increase e plus plus. Then what we have to do, we have to just find out neighbor, int neighbor equal to graph dot get rc dot get e. Okay, so after that what we have to do, we have to just check out that if our neighbor is our parent or not. Or neighbor is our parent, or neighbor is our parent of src equal to neighbor, then we have to just continue. Then we have to just continue, and then after that we have to just what you have to check, else if visited of neighbor equal to true. Else if visited of neighbor equal to true, then what we have to do, we have to just go and take a parent of neighbor equal to, then you have to do what you have to do, you have to just go and check out the parent of neighbor equal to false. Okay, parent of neighbor equal to source. Okay, source. And after that what we have to do, you have to just call this ap bridge, bridges, where we put an graph which comes from the function of ap bridge, comma disk, low, parent, answer, visited, nvr. Okay, so we just call all things, and after that what we have to do, we have to just go and update our src, low value of src equal to math insert. Okay, so let's just go and update our math.src. And then we are going to just update our math.src. I think we just come here, and then we have just go and update our math.src, low src, comma I think after the calling math.low src, comma low neighbor, no nvr. Okay, and after that what we have to do, we just go, and if low low of NVR is greater than disk of NVR, okay, then what we have to do, we have to just add temp.add src, temp.add of src, and then we just add temp.add neighbor, okay. And after that, what we have to do, we have to just go and add answer.add comp, answer.add temp, answer.add temp, okay. And after that, we just go, and this is your answer, okay. So what you are doing in this code, so in this code previously, we are taking an array list of graph, and where we just create a graph and we just add it our neighbors list u and v, and then we just create a parent, and then we just send this function, we are send this function here, okay, and we create this, okay, and then we have to just call it. And then what we have to do, I think we create another function, sorry, we just created another function, okay. Hmm. We are going to run it. I think you are getting it, okay, so we are getting it in 25, so we are going to run it, and we are getting accepted, so now we are going to submit it. So submitted. So thank you for watching this video. Thank you.